Okay, today we're going to go over systems of linear equations. This is going to be an introductory lesson, so we're not going to go too deep into it. Okay, so did you know that a group of crows is called a murder? What do you call a group of fish? You call them a school, correct? What about a group of horses? You call them a herd. And a group of ducks you call a flock. Most things that come in a group of two or more can be labeled with a special name. And that also applies to math. The special name of two or more linear equations is called a system. The definition of a system of linear equations is a set of two or more linear equations that have the same variables. So here, this is a system of linear equations. They both have the same variables, those variables being x and y, if we were to write them in slope-intercept form. They both have an x and they both have a y. This is also a system. It's two linear equations. Both of them have a x and a y. And then this here is also a system of linear equations. And I know you may be saying, well, I only see one equation here, but there's actually two. One is on top of the other. So this is also a system of linear equation. The different types of solutions. So the solution of a linear equation is the point. It's a point where both of those linear equations meet, and we represent that point as an ordered pair. So here we have two lines. These lines are parallel, so they will never meet. And since we said the solution is the point where they meet, if your system of linear equations looks like this, you're going to say that there is no solution, meaning they have no point where they meet. Here, this is also a system, but they do meet. The two lines do meet. They meet at this point right here, which is 3, -1. So I'm going to say that there is one solution. There's one place where they meet, and that place is at 3, -1. Now, when you have a situation where the lines are identical, or one line is on top of the other, like here, these two lines, they meet everywhere, correct? They meet here, 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 everywhere along this line they meet because they're one on top of the other. Since they're identical, that means that they share all points. So that means that there's infinitely many solutions since lines extend in both directions infinitely. Now let's look specifically at each of the solution types. When there's no solution, that means it's parallel lines. So what does that mean for your linear equations? That means that they have the same slope and they have different y-intercepts. So these have the same slope. As you can see, their steepness is the same, but where they cross the y-intercept is different. Same slope, different y-intercepts. Here we have one solution. When the linear system has one solution, they have different slopes. Here, this purple line is a positive slope. Red line is a negative slope. So they have different slopes. And they also have different y-intercepts. When there are infinitely many solutions, the two lines have the same slope and they have the same y-intercept because they are identical. Okay, for your exit ticket, you're going to answer in OutSchool with private message to me. And here are your two questions. First question is, when graphing a system of equations, the point where the lines intersect is the blank of the system. So what goes in that blank? And then the second question is, what is the solution of this linear system here? There's no IXL assignment for today, so I will see you tomorrow.